Hello and welcome everyone. This is Noah, and in this video we're going to look at finding x-intercepts of a quadratic function using the quadratic formula. All right, let's take a look. If we're going to use the quadratic formula for finding x-intercepts, we had best understand what the quadratic formula is. We are not going to prove it today. We'll actually prove it later on in this module. But we want to just state it now and get used to it. If we are given 0 equals ax squared plus bx plus c, then x will equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is really a formula that's so ubiquitous through math. If you're going to be doing much math at all over the next couple of years or in your career at all, this is a formula you need to be having stuck up in your brain permanently. As long as I'm thinking about that, there is a video. Pull this up. I'm just going to paste this in here. Here's a link to a song that can help you memorize it. It goes along with Pop Goes the Weasel. It's kind of cute. I never used this song to memorize it personally, but a lot of people use this and really enjoy it as a way to keep this formula in mind. Now, the nice thing about this formula is that it allows us to find the x-intercepts by just using arithmetic. We don't need to have any sort of factoring strategies or know anything else about how quadratic functions work in order to use this formula. All we need to do is know what the a, b, and c values are and plug them into the formula and then work out the arithmetic. So let's take a look at the first example. We're given the instructions say, given the quadratic functions, determine the x-intercepts of their graphs using the quadratic formula. So now we have the quadratic formula in front of us. The first function we're looking at is f of x equals 3x squared plus 14x minus 5. To find x-intercepts, actually move this down and just note, to find the x-intercepts of any function, we set the function equal to 0. And then solve for x. And the reason that we set it equal to 0 is because the x-intercepts are where the graph crosses the x-axis. And if we're on the x-axis, the y values are 0, right? If we are crossing the x-axis, the y value of those points are going to be 0. So we know the y values are 0, so we can set the function equal to 0. So in this first example, f of x equals 3x squared plus 14x minus 5. We set this to 0. So 0 equals 3x squared plus 14x minus 5. Now I'm going to identify my a, b, and c values. So a is the coefficient of x squared. It's just the 3. It does not include the x squared. It's just the number in front of it. Here b equals 14 and c equals negative 5. We want to make sure and include the signs of the numbers in here. C is not just 5, it's negative 5. All right, so we want to apply the quadratic formula. We're going to say x equals, I'll draw out my fraction bar, and I'm going to write negative 14. I plug the formula says negative b, and b is 14, so we'll have negative 14 plus or minus the square root of, inside the square root, we'll have b squared, so 14 squared, minus 4 times a, which is 3, times c, which is negative 5. Then we'll close up our square root. And then we want to divide by 2 times a. A is 3, so I put that down there. All right, so I'm plugging the a, b, and c into the formula, quadratic formula shown here on the bottom right. I'm going to zoom in on the work that we have here, the formula where we've plugged the numbers in, so that we can work through this arithmetic carefully. So we take this and we say this equals, and I want to make sure that fraction bar extends all the way across, that I don't let the negative 14 fall off the front. I want to keep that negative on top of the fraction bar, not in front of it, with the 14. So negative 14 plus or minus the square root of 14 squared is 196. Whoops. No, not everyone has that memorized. That's okay. You can either do that by hand or you can plug it into a calculator to double check yourself. Now we want minus 4 times 3 times negative 5. The two negatives are going to cancel to be a plus. And it's a little easier to do this multiplication if I do 4 times 5 first is 20, and then times 3. So 4 times 5 is 20, and then we'll go times 3, and so that'll give us 60. So this is 196 plus 60 inside the square root. On the bottom of the fraction, 2 times 3 is 6, so we'll go ahead and simplify that down there. All right, now we have negative 14 plus or minus the square root of 196 plus 60. That's going to take us all the way up to 256. And then we'll have all of this over the number 6. Let's keep going with this. Draw my fraction bar. I have negative 14 on top, plus or minus. The square root of 256 is 16. And this is all over 6. And now I'm going to break this up into two different answers. So I'll have negative 14 plus 16 all over 6. Or x equals negative 14 minus 16 all over 6. So for the first one, x equals negative 14 plus 16 on top divided by 6. That'll be 2 over 6. And that reduces to 1/3. And for the second one, x equals negative 14 minus 16 over 6. That will simplify to negative 14 minus 16 is negative 30 over 6. And then negative 30 divided by 6 is negative 5. So from this, we get the x values of the x-intercepts. So the x-intercepts are 1/3, 0, and negative 5, 0. And then in a future video, we're going to go ahead and look at using these to graph the function itself. So right now, we're just getting these x-intercepts. We'll put this all together into a graph later on. All right, so we want to go ahead and use this a couple more times in a couple more examples. Maybe run into some other things that might happen with these. So for g of x so for the next problem, moving on to the next one, we have part B, g of x equals negative 2x squared plus 5x minus 3. We want to start by set the function to 0. And so we'll have 0 equals negative 2x squared plus 5x minus 3. We'll identify the a, b, and c. So a equals negative 2, b equals 5, and c equals negative 3 here. Then we're going to plug this into the quadratic formula. Let's just write that down one more time. Quadratic formula is that x equals big long fraction. On top we have negative, my hand bumped something, sorry about that. Let's see, a little bit better. Plug into the quadratic formula, x equals big fraction on top negative b plus or minus the square root of b squared minus 4ac inside the square root. And then on the bottom of the fraction we have 2a. And after that we'll simplify. So step 4 will be simplify. And then step 5, I guess I'll say write the x-intercepts as points. And we'll use these same instructions again on part C in a few minutes. All right, so let's plug A, B, and C into our quadratic formula. We get x equals big long fraction. Negative b on top is negative 5 plus or minus the square root of b squared, so that would be 5 squared, minus 4 times a, which is negative 2, times c, which is negative 3. Extend my fraction bar out, close up the square root. On the bottom we have 2 times a is negative 2. All right, I had to make a little more room there. All right, let's zoom in on this. So we want to simplify this out. Redraw my fraction bar all the way across, being careful not to let the negative of the 5 fall off the front. Don't want to have that happen. So negative 5 plus or minus the square root of, inside we can simplify this, 5 squared is 25, and we have minus 4 times negative 2 times negative 3. There's 3 negatives, so it will stay negative. 4 times 2 is 8. 8 times 3 is 24. So 25 minus 24 inside the square root now. On the bottom we have 2 times negative 2 is negative 4. All right, on to the next line. We'll have negative 5 plus or minus. And we'll have 25 minus 24 is 1. The square root of 1 is 1. And then all over negative 5 plus or minus 1 all over negative 4. And I'll break this up now into 2 different things. We have x equals negative 5 plus 1 over negative 4, or x equals negative 5 minus 1 all over negative 4. If x equals negative 5 plus 1 over negative 4, this will simplify to negative 4 over negative 4 equals positive 1. If we have x equals negative 5 minus 1 over negative 4, this becomes negative 6 over negative 4, and that reduces to positive 3/2 as the negatives cancel out. All right, and so now we know that our x-intercepts are 1, 0, and 3/2, 0. 1 and 1 1/2. So they're pretty close together on this one. All right, moving on to part C. We'll do this one a little bit faster, hopefully. Make a little bit more room again. All right, so we'll set the function equal to 0. 0 equals x squared plus 3x minus 3. And we'll identify a equals 1, b equals 3, and c equals negative 3. So I'll set up my quadratic formula. X equals big long fraction. Negative b will become a minus 3, and then a plus or minus the square root of b squared is 3 squared, minus 4 times a is 1, times c is negative 3. And then close my square root, and then all over 2 times a is 1. And we'll start simplifying now. So we'll zoom in on this, say that this equals big long fraction, negative 3 plus or minus the square root of 3 squared is 9. We'll have 2 negatives. We have minus 4 times 1 times negative 3. 2 negatives makes a positive. 4 times 1 is 4, times 3 is 12. Close up our square root. On the bottom we have 2 times 1 is just 2. All right, this then equals, on top we'll have negative 3 plus or minus the square root of 21. and close that square root. 9 plus 12 is 21. On the bottom we have a 2. Now this is a little interesting because the square root of 21 doesn't simplify in any way. There's nothing we can pull out of this. There's no nice whole number square root of 21. So I can break this up as two separate things here. I could say x equals negative 3 plus the square root of 21 over 2, or x equals negative 3 minus the square root of 21 all over 2. But then we're stuck. The next thing we would have to do in order to simplify this is add the negative 3 and the square root of 21. But to do that, we need to have a simpler version of the square root of 21, which we don't have. So at this point, we are just done because there's no simpler way of stating these x values. Yeah, we could plug them into the calculator and get approximations, but we're not necessarily going to look for those all the time. So I'm going to write these as exact values. The x-intercepts are first the point negative 3 plus the square root of 21 all over 2 comma 0, and then the second point negative 3 minus the square root of 21 all over 2 comma 0. So these are our exact values. If we're graphing these, which we are going to do in a future video, we do want to go ahead and get the approximation so we know where to plot these points. So I will take a second and pull up a calculator and plug this in real quick. Let's see, I will just use Google. Yeah, sure, that works. Use a Geogebra calculator. Oh wait, there's an easier way of doing this. If I go to the Geogebra, there is just a graphing calculator. Oh, sorry, below that, the scientific calculator. And then we aren't worrying about all the graphing stuff. So I will have here the keyword disappeared. We want a fraction, and on top I'm going to put negative 3 plus the square root of 21, and on the bottom we'll put the number 2, and so this approximates to 0.79, and then we'll do this again. Fraction negative 3 minus the square root of 21 all over 2 gives us negative 3.79128878, etc. Let's get these written down here. So the first one, negative 3 plus the square root of 21 all over 2 approximates to 0.79, and the second one approximates to negative 3.79, and we'll just leave it like that. So if we were plotting these, we could get those approximations. But we also want to just know what's the simplest form of the exact value, so don't neglect these exact forms here. All right, that is the lesson on this. We have some now you try problems to have you practice the quadratic formula and finding the x-intercepts of a quadratic function and its parabola's graph. Go ahead and take a second to go to the mind map and look at those now you try problems, run through them, and in the next video I will walk through the solutions. Thank you much. We'll see you soon.